Aisha, Assalamu alaikum. Am I audible?
Yes.
Aisha, am I audible? How are you?
Walaikum assalam, sir. Fine, sir.
How are you, Aisha?
Fine, sir.
Okay, that's good. Please do switch on your video, Aisha. Just a second, let me share the screen again. Abdul and Galvin, please do switch on your video.
Yes, I know. I'll answer in a few.
Check. Okay. Okay, so let's start the session. Abdul, are you there? I'm asking something.
Yes.
Yeah, please do switch it on.
Yes.
Yeah. Okay, so shall we start, everyone?
Yes, sir.
Chalo, that's great. Okay, so let's start with the light chapter. So the first topic, okay, so sorry. So our light chapter is distributed or basically is divided into two major portions. First one is reflection of light, second one is refraction of light. Am I clear? So we'll start from the reflection of light. So let's understand what is reflection of light along with the properties and all the things. Okay? So first of all, the bouncing back of light rays from a smooth surface into the same medium is called reflection of light. Is that clear? Okay?
Yes, sir.
I did say something. I did say something in the start of the class. I need the
Yes,
active
sir.
participation from all of you. Chalo, that's good. Next is that, okay, so in this is the basic definition of the reflection of light. And basically in this chapter, we are going to assume that light travels in the straight line. That's why we say ray, light ray. Okay? So that means the light ray means straight line. So this is the basic property that we will be assuming in this chapter. So we have basically two types of reflection, everyone. First one is smooth reflection. Second one is diffused reflection. What is smooth reflection? When the surface is smooth, the reflected light rays will be symmetrical. It means that they would be parallel and they would be predictable. But in the diffused reflection, the surface will not be smooth. In that case, the reflected light rays will not be smooth. Basically, the reflected light rays will not be basically symmetrical. It's not like they will go in the different direction. There might be a possibility that they will go in the different direction. Is that clear?
Yes, sir.
Yes, sir.
Check. Okay, that's great. Next thing is that everyone that we know this thing that as a human being we also follow those laws of nature. Like there are some certain laws that we follow. Yes or no, everyone?
Yes, sir.
Yes,
So
sir.
these light rays also follow some laws. Aisha, are you there?
Yes, sir.
Please do switch on your video, Aisha.
Sir, there is some network problem.
Acha, ठीक है. What happened, Abdul and Galvin? Bacho, you didn't switch it on at all.
So my net is lagging a bit, sir. That's why.
अच्छा, ठीक है. Abdul. So if you do like things like this even after asking, that's not good. Okay, those who have problem, that's completely acceptable, but those who are not responding at all, even asking again and again, so that's not completely good. You are there in the class, be attentive and respond to me. And if I'm asking something, you should be doing that thing as well. Abdul,
Yes.
I'm asking something, Vijay, since the start of the class.
Yes.
What I'm asking?
To open the camera.
Yes, why are you not opening? It's 15 minutes almost.
It's not working properly. That's it.
So you should be telling me for that or
Yes.
not. If I'm
Okay.
asking something, you should say, you said, sir, I'm basically opening it. So if you have any issue, just let me know at least.
Yes.
Okay. So basically light rays follows through basically laws of reflection. So the first law of reflection is says that the angle of incidence and the angle of reflection are equal to each other. Yes or no? This is a very basic law that we know, right? So that is your laws of the first law of reflection. So in that, one more thing, incident ray makes the angle with the normal, not with the surface. Angle of incidence is measured from with the normal as a reference from the normal, yes or no, but not with the surface. So do please keep this thing in your mind. Okay. Next is the incident ray, reflected ray, and normal to the point of incidence all lie in the same plane. It means that in the same axis, two axes are taken. It could be any two axes. So they will be traveling in only two axes. No third axis will be involved in that. That's why the plane word is used. It means that 2D. Clear?
Yes.
Yes, sir.
Yes, sir.
Chalo, theek hai. Next is, okay, this is the definition of angle of incidence. So the angle made by the incident ray and the normal is called angle of incidence. The angle made by the reflected ray and the normal is called angle of reflection. So these are the two definitions. So that just to clear your confusion, that angle of reflection or incidence is not made with the surface. It is made with the normal. It is measured with the normal. Okay? Okay, so everyone, we are talking about the reflection of light. It means that if you're talking about reflection of light, we'll be having some images as well. Because if light is there, there would be image as well, right? If you are able to see the world, that is due to the reflection of light, refraction of light. So among those, so we have two types of images that we have to study in real life. That is real image and the virtual image. So now let's understand what are the differentiating factors of real image and virtual image. And this might be a hot question for your board exams that might appear and as well in your pre-board exams. Okay, those who are having the pre-boards, that might be a possibility that you should get this question in your pre-boards as well and boards as well. It's like, because when I was in 10th standard, I faced I'm not sure in which subject, like either it was math or science. I got the two same questions even in pre-boards as well as the boards. So boards questions are repetitive, so there might be a possibility that you should face this question in your board exams as well as pre-boards. Okay. So this question says that differentiate. So let's see the differentiating factors. The first thing is that real images, just so real image is formed by the actual intersection of the two light rays. At least two light rays are taken, because I have told you in the ray image form in the ray diagrams that we need at least two light rays. Yes or no? To form the image, we need at least two light rays. It can be more than two, but we need at least two light rays to form a ray diagram. So in that case, that's why I have written the intersection should be done by at least two light rays to form the real image, actual intersection. But in the virtual images, such things not happen. Basically, it is the imagination. It appears to meet when extended. Clear? It appears to meet when extended. Clear, all of you?
Yes,
Yes.
sir.
Yes, sir.
Good. Next is real image is inverted. So we know this thing, a real image is inverted means that if I'm sitting right here, my real image would be downright. It means that my head would be downwards, my body would be upwards. That is your inverted means. Second is virtual image is erect. Erect means if you are basically sitting, if I'm sitting right like this, so my image would be same. It would be, my head would be upright, my body would be downward. Clear, all of you? That is your erect. Acha, next, now let's understand the next thing. Real image can be obtained on a screen. It means that as you know, real image exists in reality. Yes, they are real. That's why they are said real images. So that means it can be obtained on a screen. But virtual images are nothing but just your illusions. So illusion means something that is going in your mind is an illusion. So you are
Yes.
not able to basically present it on the screen. Suppose that you are just imagining that basically you are roaming in street of Paris, London and Spain, whatever place you are thinking about. So obviously this is not possible to present it on a screen. That means that is nothing but the virtuality, the illusion. Okay?
Yes.
So that means that is your virtual image. Okay? So virtual images cannot be obtained on a screen. Clear, all of you?
Yes,
Yes.
sir.
Next is example of real image and virtual image. Cinema screen is an example of real image. It means that the image formed by the formed on the cinema screen is a real image of. And next thing is that retina also forms a real image. In our eye, we have studied the retina functions. So if we know this thing that the retina is the screen of the eye, so that means retina also forms, human eye also forms the real image of this world. Clear? Okay.
Yes, sir.
So you might be thinking that, sir, if our eyes also forms the real image, why is it not inverted? Actually, it is inverted, but our mind manipulates, our brain manipulates and show it upright. That's the function of brain. Okay, so don't get confused, sir. If it is upright, if it is, so why is it in, why is it real? It should be virtual. That's not. It is formed real image on the retina, but some signals goes from the retina to see it upright. Okay, so that's why we see the world in the upright manner. Otherwise we will be seeing the world just normal. If it is real, it would be inverted. Okay,
Yes, sir.
only Elvina is there in the class, bacho.
Clear.
What about you?
Yes, sir. Clear.
Good. Next is image formed by the plane mirror is a virtual image. Okay. So the image that we see in the plane mirror is nothing but a virtual image. Is that clear to all of you, bachon?
Yes.
Yes, sir.
Any doubt so far to anyone?
No, sir.
No,
No,
sir.
sir.
That's great.
No.
So this was all about the real image and the virtual image. Hope it's clear to all of you. Please do let me know, everyone.
Yes. Yes, sir.
That's great. Now
Yes.
let's understand. Now let's start the next topic, that is your image formation by the plane mirror. So image formation by the plane mirror. So we know this thing that plane mirror is a normal mirror that we use in our day-to-day life to see ourselves, to dress ourselves. Yes or no?
Yes, sir.
Yes.
Yes, sir.
Okay. Just a second. Okay, that's good. Next is, so now as you can see, we assume that the right side of the direction of light is the basically when the light is traveling in the right side, that is the direction of light. This is our assumption. So that's understand. So how like what is the type of image formed by the plane mirror? Okay. So as you can see, this is the horizontal surface. Plane mirror is basically standing vertically. Okay. So this is the object placed. So if the light ray from the object strike the surface with some angle, it will reflect back into the same medium, yes or no, with the same angle?
Yes. Yes, sir.
Good. And Ajay, let me know one thing. If the light ray is falling perpendicular to the plane mirror, what is the angle of incidence in that case?
It will reflect back in the same path.
In the same, I'm asking what is the angle, Alvina? It's an open question to all of you.
Zero.
Okay, Alvina said 0. What about rest of you? I'm asking something, everyone. It's not like
Can I
one
repeat the
student
question,
question.
sir?
90.
I'm asking what is the
No,
angle
sir.
of incidence if the
90.
Achha, Alvina, one answer only.
90, sir. 90.
90. Please listen my question again.
Yes, sir.
What is the angle of incidence if the light ray is falling perpendicular to the plane mirror? This is my question.
Sir,
Think it about.
sir,
Chat. Everyone
yes, yes,
answer me in the chat. Acha. So now acha, is that the thing? Chalo, theek hai. So now if it is 90, if it is, you are saying it, if it is 90, so angle of reflection should be 90 as well.
Yes.
But in that case, angle of reflection is not 90. It is retracing its same path. That is violating the law of reflection. But I have just told you that angle of incidence is measured with the normal. Both normal and angle of basically incident ray would be parallel to each other because the light ray is perpendicular to the surface and normal is also perpendicular. If it is line, one is also perpendicular, one is also perpendicular to this line, but they are actually parallel to each other, na? So it should be 0. So that's why the line is retracing its path. Otherwise, it would be different. The answer will be 0 degree. That's why it is retracing its path. Clear?
Yes.
So
No
both
doubt?
are parallel.
Both are parallel. That's why angle of incidence is 0. Because we measure the angle between normal and the incident ray, not with the surface. There is no catch at the surface. Clear?
Okay.
Yes,
So
sir.
it would be 0 degree. So as you can see this thing, everyone, that if I extend this line in the forward direction, they are not going to meet at all, because this line is going straight and this line is going more away from it. Okay? So but what I'm assuming, that suppose there might be a common origin point that from which the rays are originating. So that's why I have basically extended just to see whether they are intersecting or not. So when I extended the lines, yes, I got a point where the light rays are intersecting. So that point is called light, basically image formation point. Clear? Yes or no, everyone? Clear?
Yes.
Okay, that's
Yes,
good. So in plane mirror, the image formed, as you can see, the height of the image as well as the object, both are same. So image formed are same in size. And basically, if suppose you have placed the object 30 centimeter away from the plane mirror, the image will be formed behind the mirror at the same distance, 30 centimeter. When you see yourself in a mirror, if you are standing very far away from the mirror, you will see that the image also looks like you are very far away from the mirror. That is behind the mirror. Yes or no? That is the case in plane mirror. Have you observed this thing?
Yes.
Yes or no, Muchu? Have you observed this thing or not?
Yes.
Yes.
yes,
Okay.
sir.
So that's why the image distance and the object distance are equal in magnitude. We are talking about magnitude, means only number, not with the sign. So sign, if I'm saying magnitude, that means your number only. Okay. So let's talk about the properties of plane mirror. So plane mirror forms virtual and direct images and behind the mirror. The distance, image distance and the object distance are same in magnitude. Magnitude means number. The negative and positive sign shows that the image is in front of the mirror or behind the mirror. This is clear to all of you or not? Do you remember this thing, everyone?
Yes, sir.
Yes, sir.
That's good.
Yes,
Next is the size of the image and the object would be same. And the image formed by the plane mirror is laterally inverted. Can anybody tell me what do you mean by lateral inversion or laterally inverted image?
So may I?
Ha, sure, Harshit.
So basically, when you upright your right hand in the plane mirror, it is
Mhm.
shown the left hand. But if you upright your like left hand, it is shown in the mirror. It is right hand.
Okay, that's good. Anyone else? Anybody else? Aisha, Abdul, Galvin, Alvina.
Sir, if an object is placed in front of the plane mirror, it shows the opposite side of it,
Opposite
the image
side.
form.
Okay. Anybody else? Nobody. So yeah, the answer given by the Harshit and Alvina both are right. So the right appears to be left and the left appears to be right in the mirror, in the plane mirror. That phenomena is called lateral inversion, and the image formed by the lateral inversion are laterally inverted images. Clear? So when an object is placed in front of a mirror, then the right side of the object appears to become the left side of the image, and the left side of the object appears to become the right side of the image. So such type of images are called laterally inverted images. Okay. Achha, one more thing, everyone. This basically is the figure. So so this whole angle is 180 degree. So if this is 90, see this thing, this would be 90. So if this is a normal, so this would be 90 and this would be 90. Yes or no? That's how you will get 180. Both are yes or no 90 right angle. So if you have taken I from the 90 degrees, so the remaining would be 90 minus I. That is the complementary. And same with the angle of reflection. That is R is there, and the complementary of it would be 90 minus R. Got it, everyone?
Yes, sir.
Any doubt so far to anyone?
no, sir.
Sure?
Yes, sir.
Okay, that's good. Next is linear magnification. So linear magnification, see this thing everyone, that linear magnification is the ratio of the image distance to the object distance. And this linear magnification tells you whether the image is small, large or equal in size. Do you remember this thing everyone? Linear magnification. And the ratio is V by U. I'm taking magnitude because I'm talking about general case. I'm not talking about lens or mirror, because in mirror there would be minus sign here, but in the lens this would be only V by U. Yes or no, everyone?
Yes, sir.
Yes.
That's good. So if the magnitude of the magnification is less than 1, then the image would be smaller than the object. If the magnification is equals to 1, then the image would be same size. And if the magnification is greater than 1, then the image would be enlarged. So these three cases will be if the magnification is positive, it means that image is virtual and erect. And if the magnification is negative, it means that the image is real and inverted. So only negative and positive sign shows that image is real or virtual. So don't get confused in this. This is a general case. So three cases will be formed for the real and inverted case, and three case would be for the basically a virtual and erect case. Got it, everyone?
Yes, sir.
Yes.
That's good. Now let's see the next thing, that is use of plane mirror. So plane mirror is used to see ourselves. Okay, and plane mirrors are fitted at blind turns of some curvy roads. So basically at some curvy roads, we use plane mirrors to see the coming objects. On the other hand, clear all of you?
Yes, sir.
Yes.
Okay, let me know the answer in the chat of this question. Do it fast, everyone. Okay, Aisha. Do it fast, everyone. This is a very simple question. Just draw the ray diagram if you are confused. Draw the ray diagram. Basically, label the angle which is given. Check it, Galvin. Check Alvina. Arshad. Abdul,
I've given,
answer.
so that I've
अच्छा
given
ठीक है.
the
Abdul, answer. Abdul, how do you get 145? Bache? The question is asking about the angle of reflection. This is only 55 because 35 is with the surface. So 45 or 55 आपका angle of incidence. If angle of incidence is 55, so 55 would be the angle of reflection. बोलो clear है या नहीं?
Yes.
yes.
That's good. Okay. Next is the focal length of a plane mirror is infinite. Why infinite? Because plane mirror does not converge the parallel rays to a point. It's say if the light rays are coming parallel, it will go parallel to the or is basically principal axis. So that's why angle of incidence would be 0. So angle of reflection will also be 0. Yes or no? So we know this thing in the ninth. We have studied this thing in the ninth class that the parallel light rays meet at infinity. How many of you remember this thing?
Yes, sir.
Do you remember this thing? The parallel light rays meet at infinity. Ninth class angles, chapter 6, lines and angles, the property of parallel light rays.
Yes, sir.
Okay. I think so. Galvin was there with me in the ninth class standard for the maths. Galvin, do you remember? Alvina, I think so. You were also there in the ninth class. So do you
Yes.
remember? Abdul, Arshad, Aisha?
Yes.
Okay. So if the light rays are meeting at infinity, then the focal length would be infinite. So this might be an MCQ question. I'm I'm saying that with surety that there might be a question in the MCQ portion or even in the case study question, such kind of. They might be asking the focal length of a plane mirror. So most of the student will say 0 because angle of incidence they will think that is 0. So everything would be 0. No, the focal length would be infinite. Got it, everyone? Yes or no? Bolo jaldi se.
Yes.
Chalo, that's great.
Yes, sir.
ठीक है. Now let's
Yes,
talk about the image formation by the spherical mirrors. So this was all about the plane mirrors. So now let's talk about the spherical mirrors. Okay. So we have in the spherical mirrors. So basically we have two types of mirror. First one is concave. Second one is convex. Do you get this point, everyone? Yes or no?
Yes.
Yes, sir.
Good. So okay. So and the middle point of this mirror is called pole. Okay. And we know this thing that the radius is basically twice of focal length. So if you multiply the focal length by 2, you will get the radius. That is nothing but the distance from the center of curvature. Yes or no? In the circle, in the sphere, we know
Yes.
this thing that the center of curvature is basically nothing but the distance between the circumference and the center. That is your radius. Okay. And I've also given one trick to you, everyone. That is concave. Whenever you hear the word concave mirror or lens, don't like just hear. If you see the word that it is concave, it means focal length would be negative. Both lens and mirror will have focal length as negative for the concave. Second one is convex. That is also positive. Okay. So it means that if lens and mirror are given to you, so irrespective of the lens or mirror, the focal length of convex nature would be positive. Got it, everyone?
Yes.
sir.
Yes.
Yes, sir.
Chalo, that's great. Acha, why do we call the concave mirror as converging mirror? Converging mirror means that if the light rays are coming parallel, they converge, they merge all the light rays at a single point. That is your focus. So that why it basically converge. Converge means merging at a point. Okay.
Yes, sir.
Yes.
And the convex mirror is called diverging mirror because the light rays spread out after reflection from the convex mirror. So basically light rays spread out in the convex mirror. That's why it is called diverging mirror. Got it, everyone?
Yes.
Yes.
That's great. Next is concave mirror is also called converging mirror. The focal length of a concave mirror is negative. Okay? Concave mirror always form real and inverted images except in one case. So in only one case, that is the last case, when the object is placed between focus and the pole, then the image formed would be virtual and erect. Got it, everyone? Yes or no?
Yes, sir.
Any
Yes,
doubts
sir.
so far to anyone?
No, sir.
No, sir.
Sure?
Yes, sir.
Yes.
Yes, sir.
That's good. Ajay, do let me know one thing. Did we cover is this our first class of revision?
No, sir.
No,
Second
sir.
class.
Second.
Second class.
Have you done this thing?
Yes, sir. We have to do the
Yes, sir.
refraction.
Actually.
Oh, I thought this is our first class. And you didn't told me either. I just saw the schedule in that there was a first class that was basically on 4th of this January. Okay, so this is our second class now. So, ठीक है. So what was the portion we have covered in the last class? Could you please tell me?
So we have to do from the refraction.
Okay, ठीक है. So mirror formula was done. Have you solved the questions of mirror formula?
Yes.
Sure.
Yes, sir.
Check it in your copy again. ठीक है then. If you're saying that, if we have, everyone is agreeing with the point, refraction we have to run.
We have to start refraction, sir.
Refraction na? Chalo, ठीक है.
Yes.
Sorry, my
Refraction.
bad, everyone. You didn't told me that. I thought that this is our first class of the this revision. Sorry. Okay, everyone. So let's do it fast. ठीक है. Okay. So now let's understand what refraction is. So refraction is the bending of light due to the change in speed of light from going one medium to another medium obliquely. Okay, that is a refraction of light. The change in direction of light when it passes from one medium to another medium obliquely, it means that with some angle obliquely, is called refraction of light. Okay, so refraction of light takes place at boundary between the two media. Suppose that this is the media and the boundary of this medium, there would be refraction, and air and water are two different mediums, so the refraction will happen at the basically at the boundary of the media. Okay, And why do we see the refraction phenomena? We see the refraction phenomena due to the change in speed of light from going one medium to another medium. Because light's speed of light is different in different mediums. So that's why when the light ray goes from one medium to another medium, then the speed of light would change. Next is greater the difference in the speed of light. So if the light is going from the air to any very denser medium in which the speed of light is very small, so that's why we will see a very great deflection from the original path. That means the refraction would be higher. Got it, everyone?
Yes.
Yes.
That's good. Next is optically rare medium. Let's see what are the types of medium that we have. We have two types of medium. Optically rare medium, a medium in which the speed of light is more, is known as optically rarer medium. When the speed of light is having more magnitude, it means that it is optically rare medium. Optically denser medium, in which the light rays is having the speed of light is less as compared to normal. So that's why it is called optically denser medium. Right. So if the light rays are, if the light incident ray is passing from one medium to another medium, right? So if the denser medium is there, so the light ray will refract towards the normal. Okay, it will refract towards the normal. In this case, the angle of refraction would be small. That means angle of incidence would be greater than angle of refraction. Bolo clear, everyone? Yes or no?
Yes.
Yes, sir.
Second
Yes.
portion is that if the light ray is going from denser to rarer, in that case, the light ray will go away from the normal. And in that case, the angle of refraction would be greater than angle of incidence. Because if the angle would be same, I and R would be same. So that is not refraction at all. That will become reflection. Because angle I is R, angle I and R equal in reflection, not in refraction. Okay?
Okay.
Yeah. Now let's see what are the effects of refraction. So effects of refraction are object are placed under waters, appears to be raised, a pencil held obliquely and basically partly immersed in water appears to be bent at the water surface. A pool of water appears to be less deep than it actually is. The stars appear to twinkle on a night. So these are the basically or effects of refraction in the real life. Now let's talk about lateral displacement. So lateral displacement is the perpendicular distance from the original path, original light ray and the emergent ray from the glass slab. So if suppose that if the light ray is incident on a glass surface, it will refract, yes on everyone, due to the change in speed of light. And when it will emerge out, so there will be a distance between the actual, if I extend this line, this is the actual incident ray without refraction and this is the emergent ray after the refraction. So there is a displacement from the original path to the emergent path. So that displacement is called angle or basically lateral displacement. Okay? And in this case, angle of incidence is equals to angle of emergence. Got it, everyone?
Yes.
Yes,
That's
sir.
good. So the perpendicular distance between the original path of light incident ray and the emergent ray coming out of the glass slab is called lateral displacement of the emergent ray of light. Clear? Achha, one more thing, can anybody tell me if the light ray falls perpendicular to the medium, what will be the angle of refraction? Huh?
Could you please repeat, sir?
I'm saying what will be the angle of refraction if the light ray falls perpendicular on the incident or on the glass medium or any medium?
It will be 0, sir.
It will be 0. What about rest of you, everyone? No one?
Sir, I've given the answer in chat.
I'll answer in the chat. 0. Yeah. Yes, the angle of refraction would be 0. So if the light ray is falling perpendicular, so the light ray will go without any deviation. If it is falling perpendicular, so this might be a question in your board exam or in the pre-boards. The figure is given to you. What is, so instead of basically instead of basically complete diagram, they will just draw the light ray till the boundary. And they will ask you what will happen when the light ray strikes. So the light ray will go without any deflection. Okay? Clear हुआ सबको या नहीं?
Yes.
Yes.
Okay, that's great. Okay. I hope it's clear to all of you. No doubt so far to anyone?
Yes, sir.
Chalo, that's great. Okay. Next is so these were some questions. So now, when the light ray goes from rarer to denser, it bend towards normal. When the light ray goes from denser to rarer, it basically bends away from the normal. So now let's talk about the laws of refraction. So light ray also follows the laws of refraction. So two laws are there. So the incident ray, refracted ray, and the normal to the point of incidence all lie in the same plane. Only the difference would be refracted ray. Instead of reflected ray, refracted ray would be there. So the law would be same for the reflection as well. Okay, reflected and refracted. Okay, next is the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is constant for a given given pair of media. It means that if you take the angle of incidence and the angle of refraction in sine function, so the ratio would be constant. That is called refractive index. Got it, everyone? बोलो yes or no, clear है नहीं?
Yes, sir. It's clear.
ठीक है? And this law is called Snell's law. Snell's law can be written as n1 is the medium of n1 is the refractive index of medium 1 into the sine of angle of incidence is equals to n2 is the refractive index of medium 2 into sine of angle of refraction. That means sine I by sine R is equals to n2 by n1. बोलो clear हुआ है सबने everyone?
Yes.
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 And this ratio will be constant for a given pair of media. Please keep this thing in your mind. Refractive index will be constant for a given pair of media. If you're talking about air and water, the constant would be fixed. Okay, that would be constant. If you talk about water and glass, that would be also different. Okay, but it would be constant for all the pair of media. Clear, all of you? Next thing is that everyone, so the refractive index of a medium is the ratio of two similar quantities. So that's why it has no units. Next is the refractive index gives an indication of the light bending ability of that medium. So it tells you that how much light will bend. Clear? How much light will bend in that medium. So that gives the idea of the ability of the light ray. Clear, all of you, of the medium?
Yes, sir.
Any doubt so far?
No.
Good. Next is the refractive index can also be written in the ratio of speed of light rays in the two mediums. Okay, so now let's see how do we write it. So the refractive index of medium 2 with respect to medium 1 is equals to the speed of light in medium 1 to the speed of light in medium 2. So refractive index of medium 2 with respect to 1. So superscript will be taken as the reference. So V1 by V2 will be the ratio in terms of velocity. Do you get this point, everyone? And if you just reverse it, the refractive index of medium 1 with respect to 2, so the velocity would be the velocity of medium 2 by medium 1. Clear?
Sir.
Yes, बोलो बच्चों.
Yes.
ठीक है. And they both are basically are reciprocal of each other or inverse of each other. ठीक है? Next is absolute refractive index. So what does it mean, absolute refractive index? So absolute refractive index means when when your reference medium is your air. If you are calculating the refractive index with respect to air, that refractive index is called absolute refractive index. And the formula is N is equals to C by V. Clear?
Yes, sir.
Next is relative refractive index. So relative refractive index means when the light ray is going when the light is going from one medium to another medium except air. So we are talking about relative. It means that air except air, there could be any medium. So that refractive index is your relative refractive index. Got it, everyone?
Yes.
So this relative refractive index can be written as V1 by V2. So in the bracket I've written basically in terms of refractive index as well. So refractive index of medium 2 with respect to 1 can be written as ratio of refractive index of medium 2 by refractive index of medium 1. And same with the refractive index of medium 1 with respect to 2 can be written as refractive index of medium 1 divided by refractive index of medium 2. I hope it's clear to all of you. Please do let me, everyone.
Yes.
That's good. Okay. We'll do the questions in the numerical cast. Okay. So a substance having high refractive index is optically denser than another substance having lower refractive index. Okay. Greater the refractive index of a substance, more it will change the direction of a beam of light passing through it. It means that a refractive index of a medium will be higher, then it means that it will bend the lights more towards the normal. Clear? Yes or no?
Yes.
Good. Next is, okay, so this was all about the refractive index. Okay, so these were some questions. I hope it's clear to all of you. Any doubt so far to anyone?
No, sir.
Sir, I want to
Yes,
ask
Alvin.
for the formula of magnitude, m is equals minus v by u or m is equals just v by u?
M is equals to minus V by U is for mirror. M is equals to V by U is for the lens. So what we have discussed in the previous topic was the general case. I've taken the only magnitude, that's the formula. We are not talking about the it is for mirror or it is for lens. I've just given you the general formula. So if you add the negative sign, it will become the magnification for mirror. If you remove that negative sign, it will become the magnification for the lens. Clear, Alvina?
Yes, sir.
That's good. Now let's talk about the image formation by the spherical mirror. So we have two types of lenses. First is convex lens, second one is concave lens. So convex lens is called as converging lens, concave lens is called as diverging lens. Same thing, convex means the converging means the point all the parallel light rays will converge at a single point or merge at a single point. Concave diverging means the light will spread out after refraction. So the center point of the lens is called optical center. The principal focus of a convex lens is a point on which principal axis, which light parallels to the principal axis converge after passing through the lens. If the light rays are coming parallel to the principal axis, they will converge at this point. So this is the principal focus for the convex lens. Okay? The focal length of convex lens is positive. I have told you convex means positive focal length, both mirror and lens. Clear?
Yes.
Okay. Next is convex lens is a converging lens, image formation by the convex lens. So these are the image formations. So I hope it's clear to all of you. So shall we skip this portion, this convex lens portion? The image formation, is it clear to you all not? Or should I explain it? Bolo? Harshit, Galvin, Alvina, Abdul, Aisha.
Yes, so could
What
you just
should
explain it?
Acha, theek hai. So the first case is basically for the image formation where convex lens is at infinity. When the light rays are at infinity, the image formed would be at focus. The type of image would be real inverted and highly diminished. As you can see, the image is formed as a point size. Okay. Second is now we have shifted the object towards the optical center and the image would be. So now the object is at the beyond the 2f2. So the light rays will converge between 2f1 and f1. So the image would be real and inverted and diminished in size, because as you can see the size of the image is small as compared to object. Now the object is placed at 2f2. 2f2 is nothing but the center of the spherical mirror, so spherical lens. Now the object will form, the image will form at the 2f1 on the other side. So the image would be real inverted and in same size. Next one, object bit is placed between 2f2 and f2. The image formed would be beyond 2f1 in larger size. So the image would be real inverted and larger in size or enlarged size. Clear? Fifth
Yes.
case is when the object is placed at focus, the image formed would be at infinity. So the image formed would be at infinity. So the light rays will go parallel and the image would be real inverted and highly enlarged. Clear?
Yes.
Yes, sir.
Okay. Next is, now this is the case in which the virtual image is formed by the convex lens, and the object is placed between optical center and the focus. Okay. So that means the image formed would be on the same side of the lens. It would be in enlarged but virtual and erect. Clear all of you?
Yes.
Yes.
Okay, so now let's talk about the use of convex lens in real life. So use of convex lens are basically we use convex lens in spectacles to correct the hypermetropia defect. Convex lens is used in simple cameras. Convex lens is used in magnifying glasses. Okay?
Yes.
Good. So now let's talk about the concave lens. So concave lens is a diverging lens. It diverges the rays. Okay. It forms virtual and direct images irrespective of the position. And focal length of a concave lens is negative. I've told you now concave word means negative focal length. Now let's talk about the image formation by the concave lens. So image formation by the concave lens, when the rays are at infinity, the image formed would be at focus. The image formed would be virtual and direct and highly diminished. Next one is when the object is placed between infinity and optical center. Wherever you place, the image formed would be between F2 and O. And the virtual image and erect image would be formed and diminished in size. Clear all of you?
Yes, sir.
Yes, sir.
Next one would be concave lens is used in spectacles to correct the defect called myopia. Concave lens is used in Galilean telescope. It is a telescope type of telescope. Second is concave lens is used in wide angle spy hole indoors. Clear? So the door holes that you see is basically concave lenses fitted in that. Okay? So I hope it's clear to all of you, everyone.
Yes, sir.
Sure, that's great. Because in the lens formula, all the numerical portion is there. So we'll do that in the numerical session. So now let's talk about the power of a lens. So what is power of a lens, everyone? So power of a lens is basically a measure of degree of convergence. It means or divergence. It means that it tells you how much the lens can converge or diverge light rays coming parallel. Okay? So the power of a lens is the reciprocal of the focal length. It means that power of a lens can be written as 1 by f if you are taking the focal length in meter. If the focal length is in centimeter, you can take 100 by f, or you can convert the focal length into meter, then you can use this formula. It's up to you. Both the formulas are right. It's not like any different formula. You just wrote 100 centimeter. You are using 100. So 1 meter is nothing but your 100 centimeter. So that's why you have used 100 over here. Clear all of you?
Yes.
Yes.
Okay, that's great. Next is SI unit of power of a lens is diopter. So diopter is the SI unit of power of a lens. Okay? And power of a lens is positive for convex lens because focal length is positive. So power of a lens would be positive as well. And for concave lens, it would be negative because focal length is in negative. Clear all of you?
Yes,
And
sir.
suppose that everyone, if we take multiple lenses of different types, suppose that we are taking concave lens, convex lens, both in basically in the combination. So you can just add the combination just algebraically, normal P1, P2 and P3. Suppose that the convex lens is of 4 diopter, power of a lens is of negative 10 diopter. If you add them, if you take the combination of this lens, it will basically minus 6 diopter. It means that it will act as a concave lens because the power is negative. Yes or no? Power is negative, so it means that it will act as a concave lens. Got it, everyone? Yes or no, Mucho?
Yes, sir.
Any doubt so far to anyone?
No,
No.
sir.
Acha, could you please tell me the answer for this focal length? You know the answer in the chat. Aisha also answer the focal. Aisha also answer the focal length. Aisha, what is 40 bache? Is this centimeter, meter? I've just told you again. That always mention the unit. If you are not mentioning the unit, it's completely wrong. F is equals to 40, it's just a number. How do I get to know about it? Always mention unit, everyone. Yeah, that is 40 centimeter. And then nature of the lens is convex lens, because the focal length is positive in nature. Clear, all of you? Please do let me know.
Sir, I didn't understand. Why did you use centimeter?
Centimeter, because if you use meter as well, the power of a lens, the focal length would become 0.4. Because the focus, because we always get the numerical value in centimeter. So that's why I've used 100 by f. That is the only reason, nothing more than that. Clear? If you write it 0.4 meter as well, that will also correct. I'm not saying that is wrong. That's why I've said this in the start of the class, that both are correct. 100 by f and 1 by f as well. But if you're taking 1 by f, you should convert the focal length in meters if you are calculating the power of a lens. Clear?
Yes, sir.
Yes.
Chalo. Okay, everyone. So